Hello everyone. Today we will discuss a new topic, concurrent engineering. In previous lecture we have discussed the collaborative engineering. So don't think that this is a similar topic, but we will also discuss the difference in traditional engineering process, concurrent and collaborative engineering. So in this particular one slide, we will discuss this concurrent engineering, different domains and different parts, how it, it's working in nowadays in our industries and in our design and manufacturing and product development process. So the contents of my slides are as initially we will define this content engineering, then we will understand the product development process, then we will discuss the different parts of the content engineering, different methodology of the content engineering. So majorly we will focus on QFT, and then we will discuss the house of quality, the methods, then we will discuss some example case studies, and we will conclude this topic. Initially, if we want the definition of this particular topic, content engineering, so it's a stage D where all tasks involved in product development are done in parallel. So whatever the steps are involved in development of a new product, these we make it such strategy that some of the tasks could be done in parallel. So we can say it's a management or engineering philosophy for improving quality and reducing cost and lead time from product conception to product development for new product and product modification. So if you have like a new product to be developed, and if you have some certain modification in existing product, then we have to manage, or we have to arrange this the whole stage in such a way that we can reduce the cost and lead time and in that product development process. So we have to apply some special strategy. So the collaboration between all individual groups and departments within a company, we do the collaboration so that we can get whatever we have desired. So particularly the different so we do collaboration between the customer research, designers, marketing, accounting, engineering. So these are the different domains for development, or different teams we can say in a organization. So first we need to see the difference between the traditional concurrent and collaborative engineering, because we have already studied the collaborative engineering. So now we will be seeing the difference between these terms. So in the respect to with the following characteristics, we need to see the difference these term, because like if we have some time frame, means for different activities or different we can say product development steps, then in traditionally we go sequentially, means uh, whatever we have the steps, then we go for step to step, and we follow step to step procedure. And in concurrent we overlap some of the process, means we do some parallel procedure, or we are doing some like design process. So in that parallel process we can do some material, or we can plan some another activity also. Collaborative is a completely shared activity where we do collaborative study, and we manage all the things in collaboration way. So, in particular, in terms of team and tradition, there are no such we use the team, but in content engineering, we use some kind of few teams. So we make few teams that work on different domains. And in collaborative, we develop, or we make a unique team which work till the completion of the objective. The deliverable or outcome, we can say, for traditional engineering is, particularly we work for drawing on, that is our desired output. For concurrent engineering we have DMU, we can say digital mockup, that is our desired output required. And for your collaborative, we need that industrial digital mockup. That is our outcome. We need that particular term. So we majorly focus in traditionally product design or particular for traditional engineering. So in content engineering, we our main focus is to reduce the time, and for collaborative, our main focus is customer and customer needs, we can say. So the objective of the for traditional engineering is design for functionality. That is our major objective. Then for content engineering, for design for assembly, for our major objective, which we work for it. And then for in collaborative engineering, we mainly focus on our virtual manufacturing. So that is our main objective while starting any work, or if we work with that collaborative philosophy. So in product development process, because since the whole process that content engineering is related to product development, so we need to understand the different procedure of product development process. So we have already read that topic, a product development process in PDL, like product development launching in that subject. So we can go, or we can first we can see different that different design process, or different we can say that process of that product development. If we need to develop one new product, then what are the different steps we can say. So first step is idea generation, another is feasibility study, then we go for design. The design, like there are three term: form design, functional design, production design. Again we go for pilot run, final test, then we launch our final product. So in next slides we will understand the step to step procedure of the product development. So first step is idea generation. So these are the factors, or these are the main key holders which work for idea generation. So the competitors of that competitors is major thing, major element we can say. Because whenever we think for a new development, or we for new idea, then always we think about the competitors of that particular product. Then we think the suppliers, with then the R&D development team work for that ideas, then different customers feedback and customer input work for that idea generation. Then marketing, obviously that parameter work for idea generation. These are the major parameter which give inputs to your idea generation. Then we generate some kind of ideas. So the that method or techniques we use for that idea generation is propositional mapping, benchmarking, and reverse engineering. So now we will understand these three techniques. The first is perpetual mapping. So we can see in this figure that there are like different products like cocoa, the cocoa pops, and some kind of like rice crisps and wheat. So if we need to see the this particular technique performance, then we will make a benchmark kind of thing. Then we will see the whether how these particular product are lying on the particular scale. So like we compare as a like in terms of nutrient, then low to high nutrient we can see this is low nutrient, this is in high nutrient. Then taste wise we can map in on a scale, like it's a good test or bad test. We can see, or we can map it particularly. So the majorly we compare the customer perception of the available product. Then we identify the gap in the market. This is our major thing in first step. So second step is your benchmarking. So in second step we get the best product available, and then we compare our product or whatever we are thinking to roll out with the best available product. Then the base performance specification of new product is compared. Then we do reverse engineering. So maybe sometime we get a new product, or the product we have already in market. So we dismantle that product and inspect the competitor product. So whatever the competitive product is there, then we dismantle, or we do reverse engineering with that product, and so that we can see the features of that product. And if some of the features we get, that we can keep in our new product. So next step is the feasibility study. So basically main motive you all knows that, to check for feasibility test is that whether the proposed product will be useful or not. So So to see the performance specification, we do feasibility study. So we need to see the demand for proposed product, then cost of developing and producing the product, that is very much required. Then does the company have manufactured capability, that is also need to see. Then we need to see the skilled labor or person available or not. So these are the major steps. Now in next is the design step of the product development. So there are majorly three terms: form design, functional design, and production design. So particularly we use the form design for physical appearance of the product. Then functional design, that performance is related to performance of the product. And product design, then we decide that how we will manufacture the product, what will be the manufacturing process, and what will be the steps for manufacturing. So these are the different three terms. So particularly the we will functional design, we will see the design specific, we will get the parameter, and from product design we will get the manufacturing specifications. Then after that we will do pilot run and test. So whatever we have decided the product, for that we will do some testing, and then we will get the final design process plan. So for pilot run we make prototype, then we test it, and we do some adjustment if required. Then we do some final specification, or final specification is decided. Then at last we launch our product, or product launching process. So we do manufacturing process, whatever we have decided, the manufacturing process planning and all. And then product is marketed to buying development. So the marketing process is carried out. So initially we have discussed the product, like we can say product, if we don't want to develop new product, then different steps. Now we will see that concurrent engineering, there are two things. That traditional process was linear, and as we have seen in initial slide, that difference on in this term. So linearly, like traditionally we do in this way, that sequentially means, so this is the customer, uh, so customer inputs will goes as a product concept to the marketing person. So market personnel will analyze, and then it will give performance specs to the design and manufacturing engineers. And then again he whatever the outcome will be from him, then it will be sent to your production personnel. So then our product will be manufactured. So this was the earlier traditional process we were following in last decade. Now we have a collaborative, and we can say the concurrent engineering, that is team collaboration. So in a team we work all together, and whatever inputs and suggestions, whatever the idea is that we discuss, and then we put it at once. So this is our concurrent engineering philosophy. So we need to say why we need that concurrent engineering. So because that market change is major factor. So nowadays market is changing, and as per the we can say the customer needs is changing. That's why we need such kind of new philosophy. Then companies must keep pace with changing markets. So companies need to be changed as per the needs of the market or customer. We can say decision made sooner rather than later. So decision making should be faster, so that we can catch it very in less time. And reduce eliminate repetition of task, that is also required if we not reduce the repetition. Then reducing the waste and reworking of the design, that needs concrete design. Then product quicker to market, so that whatever the product is manufactured, it must be go very fast in market, and to maximize the company profit and company, uh, so the the company operates and more efficiently. That's why we need that concurrent engineering. So to make the decision concurrently, the team knows the design goals and objectives, must know, and the team is aware of the interrelationship between all aspects of the design process, that is required to make to take a decision concurrently, that is required. So the methods of concurrent engineering is important. So the concurrent engineering, the application of a mixture of all following techniques to evaluate the total life cycle cost and quality. So our objective is to evaluate the total life cycle cost and quality. So for that we need certain techniques. So these are the techniques which are being used in concurrent engineering. So like we have quality function deployment, QFD technique, design for manufacturing guidelines, design science, design for assembly, the Teguchi method of for robust design, manufacturing process design rules, computer aided design for manufacturing, group technology, failure mode and effect analysis, value engineering. So most of these techniques are we have understood in different subjects, we can say, like for design for manufacturing guidelines, then design science or design for assembly, Taguchi method we already know, the optimized technique we have already learned, manufacturing process design rules, computer aided DFM is a, we have already understood in CAM or CAD part. Group technology we have already discussed in previous unit. Failure mode effect analysis we have already read in one subject, we can say, that quality then quality assurance, value engineering. So these are the techniques maybe we have read in earlier subjects or earlier units. So I will mainly focus on first part, that quality function deployment, QF. So the collection of metrics that convert the need of the customer into technical specs in all at stages design and manufacturing process. We are mainly focusing that stages like design and manufacturing process. So we will collect such kind of parameter that will convert the need of the customer into our technical specification, that is done by this technique quality function deployment. So the main technique we use for this particular is house of quality. So house of quality, there are six we can say steps. So step one is customer requirement prioritized. So we scale or we in percentage we do that customer requirement, we identify that. Then we do competitive product evaluation. Then engineering characteristics are find out. Then interrelationship are find out between step one and three. So customer requirement is linked to engineering characteristics. In step 5 we will we will find out the relation between engineering characteristics. Then we see that or we find out the targets of for new product. So if we for to understand the particular these six steps, we will take a example of water pond alarm. So for that particular alarm, we identify for in first step we will identify the customer requirement and priority means we do prioritize so that we can say which one is more important, and we scale or we identify we do weighting for each parameter. So these are the different attribute for water pond alarm, and we give some weightage to each parameters. Then second step is compare product competitors. So the like we have five competitor for that. Then we compare the product in different grade A and B. So like then for these are our attributes for our product. So and these are the different A and B. There are two, we can say, two competitors. So that we need to see whether we are just comparing the product to our competitor. Third step is identifying the engineering characteristics. Here we will identify the engineering characteristics. So these are the attributes and these are the engineering characteristics of our product. So as per these, like sensitive to water level, durability of the product, make a loud noise that is required, expensive, low expensive, you can say, small, and it should look good. So weighting we are giving like characteristics, complexity of the circuit, energy efficiency, material forecasting, and cost of sales. These are the engineering characteristics. So in next step, we identify the strength of interrelation between the customer requirement and engineering software. In these both, we will see the relationship in these both. So particularly we need to understand these signs. So means first, if we have positive correlation, then we will do 1 plus. If we have strong positive correlation, then we will allot double plus. And if we have nothing, then we will keep it blank. If we have negative correlation, then we will put one sign. If we have strong negative correlation, then we will put double minus. So for each parameter, we will for attribute we will compare it. Then we will see that sensitive water level is, as we need that parameter highly, then we need a more complex circuit, so that will be plus 2. Then again energy efficiency sensitivity, that will link plus 1, means it's less correlation. Same with the cost of the sensor will be high, because that is more linked to the sensitivity. Again durability, durability, we need to see the material that is very much required. That's how these parameters are linked and these are interrelated. So next step is to interpret the matrix. How we are interpreting. If we need to see the parameters, then I've already told that plus two plus sign means these are highly likely to be dependent on particularly circuit. Sensitivity is completely dependent on circuit. Again, one minus means that if we increase the noise level, that will reduce the energy efficiency. That's why it's a on negative effect. So next is like if we have this parameter plus means for durability we will check the material will means the material quality will affect the durability. Again, inexpensive means the complexity, add this complexity will increase, the cost will be high. Again, the cost of sensor is will affect the expensiveness. Then we will identify the correlation between the engineering characteristics, or we can say these engineering characteristics, how these are linked. So we can say both these will be linked with we can say like two parameters. We can say as increase in complexity of circuit that could require more costly sensor, and the complex circuit that we have more parts that will reduce the energy efficiency. So the you can say the linkage, or we can say the correlation between each characteristic. So as a we can say if we have some good quality sensor that will improve the energy efficiency, right? So this will be these two will be linked. Then we will next I will identify the we can say a new product, or we will identify the targets for new product. So the objective we are can say like we have two computer A and B, and this is our design and our whatever our targets. So then we have different we can say characteristics, complexity, energy efficiency. These are our specifications. So like for a competitor we have 25, we have 120 battery life, we can say material type, ABS we use. This is the cost of sensors. So these are the parts for a competitor, B competitor. This is for our design, and this is our target. So this will we will identify in last step. Now we will do now last we will do after after fabrication, after product manufacturing, we will do the performance test of that particular pond alarm. So in terms of casing seal, we will check the casing seal, then we will check the sensitivity, we will check the battery life, ability to withstand extreme weather, alarm volume. So these are the procedure to do this test, and we need to be perform our product at least these level is required. Now we will see the case study for a desktop computer. So there are like two or three steps in the design stage. The design could specify the following: that reusable computer component, recycle material, minimum toxic material. So at design stage we need to see these parameters. These are very much important. At manufacturing level we use the ethical work practice, source of raw material. We will use the clean manufacturing process. We will minimize the transport of the components. These are our major objective while manufacturing the product. At user level we will see it should consume low power, the service item rather than replaceable disk drive refrigerator. These are for desktop item. So disposable, the design for disassembly use easily dismantle fixing that is much required, so that it could disassemble very fast, and identify materials used for recycling that is required, and minimize mixed material to facilitate separation later. So these are the identify some parameters for different steps for we can say development of a desktop computer, or like if we consider a new product as a desktop computer, then these are the steps, or these are the parameters which are required. Then one more important is the testing part. So we need to see the accelerated testing. So we need to see what is the role that is used for to expect the life is long to capture live data, and live data that is needed to estimate the reliability of the product. So for estimation of the reliability, we do the acceleration test. So we are conduct this test on sample prototype. The test cause the product to fail in same manner as normal use, and test time is greatly reduced. So the product is quicker to market, so that we can launch in market very very fast in low time, and low development and warranty cost. So majorly we can say there are two methods, that qualitative or quantitative for acceleration test. So first we will see the qualitative acceleration test. This is used to reveal probable failure modes, and it's a good test quickly reveal failure because this is quickly we can get the failure modes, and we could improve the design product performance on small number of samples, product subjected to one severe level of stress. That is that is we do in our qualitative acceleration test. So like stress cycling or hot to cold, that is our one example of the acceleration test for qualitative. Product intact, that we pass. Then failure, if failure is if our product is failure, then we will take the actions to eliminate the cause of failure. So we'll identify the cause of failure, then we will eliminate this. So the test is the only test condition is encountered in real use, so cannot be used to quantify the life of product. So here we are not quantifying the life of the product, but we are checking that our whether product is pass or fail. So if it is some failure is happen, then we will eliminate the cause of that failure, that is required in this qualitative accelerated test. Second is quantitative acceleration life test. So we quantify the life of the product and the control application of accelerate stress condition to simulate the product failure. So what we do, we 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 do or we check the we apply the accelerated stress condition to simulate the product failure. So the reduction in time to failure for the product, we get that parameter time to failure for a product, and the data is used to estimate the reliability of the product. Again, our main target is to estimate the reliability of the product. This again one example of a washing machine to last for 10 years in normal use. Expected typical household use 3 times a week for a wash cycle that will last for 2 hours on an average. That is expected use. Then we need to see what type of test should be used, how long must machine survive during the test, total hours life required for machine is, then first we need to total hour life, this is total hours 3120, then we will use the quantitative qualification and run the machine constantly for 3120 hours. Like if another we have example explain why this test is used for some product. Some product have a long life, need to test reliability, that is very much required, and quantify life of product equal to warranty, so that we can say this is the warranty of the product. So the washing machine being used for 2 hours per day, 3 days per week in normal use, what kind of acceleration testing will be defined. So we do the quantitative test, so the data is used to determine the expected normal life of product. So during the testing, the washing machine can run like 3000 operating hours before failing. So recommended a suitable guarantee period, so that we can recommend for that product that we will give that 10 years guarantee period. So this is the way we can calculate the warranty period for a product. So this is the whole topic around content engineering. So these are the sample we have covered the product cycle, or we can say product process. We have seen the difference between traditional, concurrent, and collaborative engineering. And in concurrent engineering, we have seen different steps of QFD method, and how we have taken the example of bond, and we have understand the different procedure in 6 steps we have understand, and we have discussed few example case studies. This is our whole topic on content engineering. Thank you very much.